to GCSE Maths Help. Today we're going to be looking at simultaneous equations exam paper questions. This video is a follow-on from our simultaneous equations key points video, which I will link in the bio below. If you haven't watched that video yet, you might find it useful before looking at exam questions. Let's get started. The first question we're going to look at is a linear simultaneous equations question that's masquerading as a sequences question. So the question says, a linear sequence starts with a plus 2b, a plus 6b, a plus 10b. The second term has a value of 8, the fifth term has a value of 44. Work out the values of a and b. So let's start with what we know. We know that the second term has a value of 8, and the fifth term has a value of 44. But we don't know what this fifth term is yet, so let's start with there. The sequence, we're adding 4b each time. So the fourth term is going to be a plus 14b. The fifth term is going to be a plus 18b. So now we've got two equations here. We've got a plus 6b is equal to 8. And we've got a plus 18b is equal to 44. So these are our simultaneous equations. So we're going to start by putting a on one side of the equations and b in the number on the other side. So on the first one, let's minus 6b from both sides to give us a equals 8 minus 6b. And let's do the same for the other equation. Let's minus 18b from both sides to give us a equals 44 minus 18b. So we have two equations here that are equal to a, so we can write that they're equal to each other. So 8 minus 6b is equal to 44 minus 18b. So because we've only got one variable now, this is an equation that we can solve. So if we add 18b to both sides, we get 8 plus 12b is equal to 44. We can minus 8 from both sides to give us 12b is equal to 36. Divide both sides by 12, so b is equal to 3. So now we can find a value for a. We've got a plus 6b is equal to 8, but we know that b is equal to 3, so that's 8 plus 6 times 3 is 18 is equal to 8, so a must equal minus 10. So let's put our values into the other equation to check that it's right. So a plus 18b equals 44 is minus 10 plus 3 times 18, which is 54, is equal to 44. So that's minus 10 plus 54 is equal to 44, which is right. So we know that we've got the right values for a and for b. So this next question asks us to solve simultaneous equations using a graph. The question says, here is the graph of 4x minus 3y equals 12 for the values of x from 0 to 4. By drawing a second graph on the grid, work out an approximate solution to the simultaneous equations 4x minus 3y equals 12 and 3x plus 2y equals 6. So we know from our key points video that the way to solve simultaneous equations using a graph is to find the points where the two lines cross. So we know that if we draw the line of the second equation, 3x plus 2y equals 6, onto the graph paper, we can see where the two lines cross, and that point will be our answer. We also know that these equations are both linear, so there's only going to be one point where they cross because they're two straight lines. So let's start plotting some points. So I'm going to draw us a little table for our x and our y values. So I'm going to start with the x values from 0 to 4 because that's the range that they use for the other line. So let's start there. So for this equation here, 3x plus 2y equals 6. When x equals 0, y equals 3. When x equals 1, y equals 1.5. When x equals 2, y equals 0. When x equals 3, y equals minus 1.5. When x equals 4, y equals minus 3. So let's plot those points on the graph. So we've got x equals 0, y equals 3. X equals 1, y equals 1.5, x equals 2, y equals 0, x equals 3, y equals 1.5, x equals 4, y equals minus 3. So if we join up our dots here, we've got the line of our second equation and we can see where the two lines cross. This is going to be our answer. So we've got an x value of 2.5 and a y value of minus 0.7, which is our answer of an approximate solution to the simultaneous equations. This is one of those questions where the examiner will give you marks even if your answer is slightly different from what they've got written down, as long as you've drawn your graph correctly and the answer that you've given is the point on your graph where the two lines cross. Even if it's slightly different from their mark scheme, as long as you've interpreted the graph and shown that you know that the answer is where the two lines cross, you'll get the marks regardless. This next question is a difficult one. There are quadratic simultaneous equations to solve, but with the added problem of another unknown number in there. As you can see from the question number, it was one of the last questions on the paper, so it's going to be one of the more difficult ones, and it was a lengthy one as it's worth 8 marks in total. But don't panic, we'll break it down into what we've learnt about simultaneous equations. It was also on a paper 3, which means you're allowed to use your calculator if we need to. So let's read the question slowly and calmly. The line y equals 3x plus p and the circle x squared plus y squared equals 53 intersect at points A and B. P is a positive integer. Show that the x coordinates of points A and B satisfy the equation 10x squared plus 6px plus p squared minus 53 is equal to 0. So let's have a little think about what we know. We know that we can solve simultaneous equations on a graph by looking at where the two lines intersect. So coordinates A and B in the question are the answers to solving the simultaneous equations. We also know from the key points video how to solve simultaneous equations when there's an x squared involved. We substitute one of the letters with the linear equation and put it into the quadratic equation, so we only have one variable to worry about. So because part A deals with x's and p's, it must be y that we're substituting. So we're going to rearrange the circle equation, but instead of having y in there, we're going to substitute it with our 3x plus p. So we've got x squared plus 3x plus p in a bracket, and then have a look what happened to the y originally. It was squared, so we need to make sure we square our substitute as well, is equal to 53. So let's start timesing that out. We've got x squared plus 9x squared, because the 3 needs to be squared as well, plus 3px plus 3px plus p squared is equal to 53. So let's gather up our like terms to give us 10x squared plus 6px plus p squared, and then we'll minus 53 from both sides, is equal to 0, which was the equation that we were aiming for. Now part B of the question states the coordinates for A are 2, 7. Work out the coordinates of B. You must show your working. So we said before that the coordinates A and B are the solutions to the simultaneous equations. So they've given us one of the answers, we need to find the second one. But first we need to sort out the extra variable p. Now usually in these types of long questions, the first part of the question is helpful in solving the second part. So let's start there. So we know that 10x squared plus 6px plus p squared minus 53 is equal to 0. But now we have an x value from our A coordinate here, so we can put 2 into this equation to help us find p. So 2 squared times 10 is 40, plus 2 times 6 times p is 12p, plus p squared minus 53 is equal to 0. So let's rearrange that to make it look like one of our usual quadratic equations. We've got p squared plus 12p, and then minus 53 plus 40 is minus 13 is equal to 0. So to factorise this, we need two numbers that times together to make minus 13 and add together to make 12. So in our brackets, we've got p plus 13, or p minus 1 is equal to 0. So if this bracket is equal to 0, p is equal to minus 13. This bracket is equal to 0, p is equal to 1. Now, if you remember, part A of the question said that p was a positive integer. So from these two values here, we know that p equals 1 is the one that we're looking for. So now that we've got a value for p, we can go back to solving the original simultaneous equations. So we've got 10x squared plus 6 times 1, because p equals 1 now, is 6x, plus 1 squared, minus 53 is equal to 0. So we've got 10x squared plus 6x minus 52 is equal to 0. So this equation is going to be a little bit difficult to factorise because there's a 10 in front of the x squared. I've got a whole other video on my YouTube page about factorising these kind of equations, so I'm not going to go into a massive amount of detail here. I'm going to start by dividing everything by 2, so that leaves us with 5x squared plus 3x minus 26 is equal to 0. So we're looking for two numbers here that times together to make minus 130, because that's 5 times minus 26, but add together to make 3. So in our brackets, we're going to have 5x plus 13, and we're going to have x minus 2, which we would expect because we were told that the x coordinate for A is 2. So if this bracket equals 0, we've got minus 13 divided by 5. This bracket equals 0, we've got x is equal to 2, which we already know. So I'm going to rewrite the minus 13 over 5 as minus 2.6, because the question that we're looking at is looking at coordinates. So writing it as a decimal is a little bit more usual for coordinates. So now we've got the x coordinate for B, we can go about finding the y coordinate. So if we go back to our original equation, we've got y equals 3x plus p. So that's y equals 3 times minus 2.6 plus 1 that we worked out p to be. Y is equal to minus 6.8. So because the question asked us to work out the coordinates of B, we need to write our answer as coordinates. So B is equal to minus 2.6 minus 6.8. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.